Hello everyone, welcome to complex number session. So now in the last session we have seen the modulus, complex number modulus of a complex number. So in the organoid plane, so how we are representing in the organoid plane, like where here the point pxy is there, and as I was telling in the last videos of the organoid plane, so where the real axis is the x-axis and y-axis represents the imaginary point. The modulus of complex number is the distance of the point on the organoid plane. Okay, so modulus is this is modulus. So modulus of complex number, modulus distance is a distance of the point, distance of the point on the organoid plane, on the organoid plane from the origin, from the origin. So that means, so last session we told that if z equal to x plus y, z equal to x plus iy, mod z is equal to square root of x square plus y square. And you have to, so one important point is mod z is always greater than 0. Mod z is always greater than 0. Okay. And second one, you have to remember that all complex numbers having the same modulus lie on a circle with center as origin, and radius r is equal to mod z. You see here, all complex numbers having the same modulus, okay, lie on a circle with the center as origin and radius r equal to mod z. So what do you mean by this is, for example, I have a complex number, okay, 5 plus say 0i. This is a complex number, right? Yes. So here y equal to 0 and x equal to, the real part is 5 and imaginary part is 0. And what is the modulus of this? Modulus of this is what? Square root of 5 square plus 0 square, which is 5. Similarly, what is 0 plus 5i? So this will be 0 square plus 5 square, which is 5. If you see, this is one complex number, this is another complex number. Both modulus are 5. Okay. And if I take another complex number, even minus 5 plus 0i. So this is also 5 square plus 0 square, which is 5. I mean, though it will be minus 5 whole square will be 5. Okay. Similarly, you take another one, 0 minus 5i. This is also 0 minus 5i is how much? 0 square plus minus 5 whole square, which is again 5. Take another one, say 3 plus 4i. Now you take this one. 3 plus 4 is 3 square plus 4 square. This is also 5. Okay, you take another one, minus 4 plus 3i. This is also square root of minus 4 whole square plus 3 square. This is also 5. If you see, all these complex numbers have the same modulus. That means if you point this in an organoid plane, they lie on a circle. So if you point this on an organoid plane, they lie on a circle actually. They lie on a circle. That means, so if I take this plane, okay, now you can plot it, okay, you can plot it here, like, for example, 5 plus 0a, where it lies here. Okay, this is 5 plus 0, right? 5 comma 0. Okay, I'm just putting. Next is 0 plus 5a is here. 0 comma 5. Next 3 plus 4a also we got, right? 3 and 4 is here. And minus 5 plus 0 is also there, right? Yes. minus 5 comma 0. Uh, Here minus 5 comma 0 is what here, minus 5 comma 0, and minus 4 plus 3i is also there. Okay, this is minus 4 comma 3. Okay, if you can join all this. I'm just drawing like this. Okay, I'm just drawing like this. You can draw all this. So all these points lie on a circle. This is a circle. All these points lie on a circle. This or this one. Okay. Now, so now next we'll see what is argument of a complex number. Argument of a complex number. So argument of a complex number. So now let us represent the same argon plane. It will be easy to understand. Now I have this. Now let me draw like this. So now let me draw here an argon plane which represents P x comma y. Okay. And now this makes angle theta. Okay, what is angle theta? Theta is angle made by line segment. Angle made by line segment joining the point on the complex plane. On the complex plane. Okay. On the complex plane representing the complex number. Representing the complex number. Okay. With the positive real axis. So this is your real axis, right? This is your real axis, which is x-axis. So, and the complex plane is this one. So, a line segment joining the point on the complex plane represent the complex with the positive real axis. So, this is what we call it as theta. And argument of, suppose if I have, okay, so argument of z is nothing but this represent argument of complex number. Argument of complex number. Okay. So, this is what your argument of complex number. Argument of z, and argument of z will be theta. Theta. Okay. And so generally we have we can represent two types of arguments. One is general argument. General argument. Okay. So general argument is, say, now let me take one example. With an example you'll understand. Okay. Now let me take one line here, and this is your P. Let us take 1 comma 1. So when I say 1 comma 1, what is mean? Z is equal to 1 plus x, right? Z is equal to 1 plus x. Z is equal to 1 plus x. Okay, Z is equal to 1 plus x. That means 1 comma. And so when I say 1 comma 1, what will be theta value? Now you see. So that means this part is 1 and this part is also 1. And obviously, if I take tan theta is how much? 1 by 1. Opposite side by adjacent side. Okay, so theta will be pi by 4. Theta will be pi by 4. But the general argument tells that theta will be 2n, in this example, 2n pi plus pi by 4. I mean, so this is your general value of argument of z. General value of why it is 2n pi plus pi by 4 is, see, now if I rotate 2 pi times, that means if I from here, if I keep on rotating and again if I come 2 pi times, again I'll come to the same place. That means if n equal to 0, theta equal to pi by 4. N equal to 1, substitute here, n equal to 0, theta equal to pi by 4. Theta equal to n equal to 1, 2 pi plus pi by 4. How much? 2 pi plus pi by 4 is how much? 9 pi by 4. Okay? Like that, the general, that means any rotations, thus complete rotation will be one rotation. So it will be 2n pi plus pi by 4. That means the general argument will be, so here it is, in this example, it is pi by 4. But general argument will be 2n pi plus theta. 2n pi plus theta is the general argument, where n belongs to integers. N belongs to integer. Now, what is the next one is general argument. What is the next one? So I'll write here again. Okay. So the next one is principal value of argument. First is a general argument. Principal value of argument. See, generally in exam questions, if they specify just argument, means you have to go with principal value of argument. If they specify explicitly that clearly that general value of argument, means you can go there. But if they go with principal value of argument, means you have to go in this way only. Principal value of argument. Okay. So this one means here theta value lies between minus pi less than theta less than or equal to pi. So if theta lies here, this will be principal value of argument. Okay. So the unique value of theta where it lies between minus pi less than theta less than or equal to pi. So it is principal value of argument. Okay. Now, how we will find the principal value of argument, we will see. Okay. Now we see, we have 4 cases. We will see that 4 cases. So how to find principal value of argument? How to find principal value of argument. Okay. Now case 1, first case. Now let me draw like this. So now what I'll do is, now I have like this, my organ plane representation. Okay. Now I have like this. Now my complex number P lies here. Okay. Right. So P x comma y. If my P lies here, this will be your theta. So here Z, this is your Z. P represents the point on the organ plane, which is complex number. Now here, what is the meaning if Z lies in first quadrant? This is first quadrant, right? This is your, in your coordinate system, this is your first quadrant, second quadrant, third quadrant, fourth quadrant. Okay. If Z lies in the first quadrant, okay, Z lies in the first quadrant. Okay. Then so this principal value of argument is also called amplitude. Remember, amplitude. This principal value of argument is also called amplitude. So if Z lies in the first argument, okay, then, so here I'll say amplitude of Z will be your theta. So your Z will be theta. So amplitude of Z is equal to theta. So this is this angle. Okay. Now in the second case we will see. In the second case. Second case what it tells. Now my complex number. Now you see my complex number now lies here. That is the second quadrant. In the second quadrant my complex number lies. That means here. So Z P of x comma y. In my second quadrant it lies. Now let this angle be say alpha. Let this angle be alpha. Now here if Z lies in the second quadrant. Z lies in second quadrant. Then amplitude of Z. So from here if you measure it will be theta here. So this still will be theta, but I want in terms of alpha. So what will be in terms of alpha? See, from here if you measure, so this is alpha, this is theta. So if this is alpha, so what will be this angle? Which will be pi minus alpha. Pi minus alpha is nothing but your theta. So which is nothing but theta. That's all. See, if you want, you can remember also. First quadrant means theta. Second quadrant means whatever the angle this is making, pi minus alpha. Okay, that is what you have to think. Now, third quadrant now. Now, if the complex number lies quadrant. See, this one you understood, right? How I got? So, this now this line is making alpha with the axis. Now, what do you mean by this now? If this is alpha, from here I will be counting, which is theta. So, the same theta, if the same theta is now equal to pi minus alpha. Why? Because if this is alpha, this will be pi minus alpha. Because pi minus alpha plus alpha, this is 180 degrees actually. Okay, that is equal to theta now. Now let me take another one. Now if Z lies in the third quadrant, so if Z lies in the third quadrant, if Z lies in the third quadrant here, now you see it. If Z lies in the third quadrant, now let us take like this. This will be your alpha. This will be your alpha. Okay. Now if Z lies in the third quadrant, third quadrant. Now if you remember, theta should always lie between minus pi to pi. So I cannot count from here to here. If I count from here to here, it will be, if I count from here to here, it will be 180. See, if I count from here to here, see, if I count from here to here, it will be 180. And from here to 180 plus alpha, I cannot count here. But from here, I can count. From here, I can count. So how much? So this will be now your theta. So then amplitude of Z. So this I cannot count. So then amplitude of Z is equal to theta. So which is equal to, see, this will be equal to minus of pi minus alpha. That means that means I'm coming in the clockwise direction. If I'm coming in the clockwise direction, it will be minus. If I'm going in the anti-clockwise direction, it is plus. So it will be now, see, if this entire thing is pi, this is pi minus alpha, but it is minus because I'm coming in the clockwise direction. Okay, that's right. See, now I cannot go in anti-clockwise direction for the third quadrant because if I go in this direction, it will be 180 plus. But my principal argument always lies between in this range. Minus pi less than theta less than equal to pi. So it will be now, which will be now alpha minus pi. Alpha minus pi. Now fourth one will see. Fourth one. Fourth case. Now what will be fourth case now? If Z lies in the fourth quadrant now. That means this one. So Z lies in the fourth quadrant. Now that is here. Okay. Now, let us take this as theta. So if Z lies in fourth quadrant, then amplitude of Z. See, if I measure from the first quadrant, it is in this direction. I'm measuring in this direction. That is anti-clockwise direction. Now here I'm measuring in the clockwise direction. So amplitude of Z. So amplitude of Z, which will be minus theta, because in the clockwise direction I'm coming, right? In the clockwise direction, it is minus theta. Okay. So if you see here, suppose if my complex number is Z is equal to A plus IB. In this case, your A is positive, B is also positive. Okay. Because in the first quadrant. Here in the second quadrant, here A is negative because it is coming to the left, and B is positive. Here A negative, B also negative. Right here, A positive, B negative. Okay. This is how you have to do that. Now, so whenever they tell that argument means it is a principal value of argument. If they give the general argument means you have to use 2n pi plus that angle. If they ask amplitude also means principal value of argument. Okay. Now let us see some one or two examples. Now find amplitude. Okay. Find amplitude of 1 plus root 3i by root 3 plus I. See, whenever I get like this, first I have to convert this to single complex form. That means I have to convert everything to A plus IB form. Okay. Now that means the denominator I have to make it as a real number. That means rationalization. We are told, right? 1 plus root 3i. Okay. And then into root 3 minus I by root 3 plus I into root 3 minus I. Because numerator and denominator I am multiplying now. Now this will be 3. Okay. Minus I square. Okay. Now this will be root 3 minus I plus 3i. Okay. Minus root 3 I square. So this will be root 3 minus I. This will be minus 2i. Sorry. Minus root 3 means plus root 3. Okay. And 1 plus root 3i. Okay. Root 3i. This will be 2i, right? Plus 2i. 3i minus I, 2i. Now 3 plus 1. Okay. So this will be now 2 root 3 plus 2i by 4. Now if I take 2 common, it will be root 3 plus I by 2. Now root 3 plus I by 2 means this I can write how much? Root 3 by 2 plus I into 1 by 2. Now if I take a complex number here, this is your real part and this is your imaginary part. Both lies in the first quadrant, right? Both lies in your first quadrant. Now if I draw a line like this, so this will be root 3 by 2, right? And this will be how much? 1 by 2. Because this is your y coordinate and this is your x coordinate. Then what is theta? So let me take tan theta. Tan theta will be 1 by 2 by root 3 by 2. So 1 by 2 into 2 by root 3, which is 1 by root 3. Okay, 1 by root 3. Then what is theta then? Pi by 6. So this is your amplitude. Pi by 6. See, if it is a general means you have to add 2n pi plus, but here it is a principal value amplitude. So like that I am solving. Root 3 by 2 plus I into 1 by 2 tan theta equal to this one. So Understood everyone? So if you have any doubt, you can pause the video and also see that. Next. Now, now let us take another one, another example. Find the find the amplitude of find the amplitude of, okay, root 7 minus 2 into I. Just see. Just see what is given. Amplitude of root 7 minus 2 into I. That means if I draw a organoid plane like this, okay, if I draw an organoid plane like this, your x-axis, there is no real. Only everything is only the imaginary. That means here it will be root 7 minus 2. That means this is your line. This is your line. Then what is the angle? Angle is this one with how much x-axis it is making? Pi by 2. So this will be your pi by 2. Amplitude is pi by 2. Because root 7 minus 2i, there is no x-axis, only the imaginary part. So angle is your pi by 2. That because we have to measure the line passing from the origin that is making the x-axis. That now it is on the y-axis. Y-axis is always perpendicular to x-axis. So the principal argument or amplitude is pi by 2. Okay. So now we'll see one more scenario, like for z is equal to, for z is equal to 1 minus I root 3. 1 minus I root. So where is your, now if you draw a graph, your x-axis is positive, but your imaginary is negative. That means it will be in fourth quadrant. That means this part. So this part is 1 and this part is root 3. So what will be your tan theta? Tan theta will be root 3. Tan theta will be root 3. And so theta will be pi by 3. But since it is in the fourth quadrant, what we have seen in the fourth case, since it is in the fourth quadrant, it will be minus theta, right? It will be minus theta. So which will be your, just so which will be your, so your amplitude will be minus pi by 3. Minus pi by 3. Okay? This is how you have to write. And what is your general argument? General argument will be, you have to add 2n pi. 2n pi minus pi by 3. Because it is 2n pi plus theta. Theta is your minus pi by 3. Your general argument. Your general argument. Okay? Let me be clear here. This is general argument. Is 2n pi minus pi by 3. Okay? Now, take down for another problem. Z is equal to minus 1 minus I root 3. Now your complex number is where? Here negative, here also negative. That means here. That means this will be your 1 and this will be your root 3. So what will be your angle? Again, tan theta is equal to root 3 by 1, which is your pi by 3. But if your angle, if your complex number lies in third quadrant, what we have seen, case 3, alpha minus pi. What is your alpha? Pi by 3. So your amplitude will be alpha minus pi by 3. Pi by 3 minus pi. How much it is? Minus 2 pi by 3. So what is your general argument? General argument will be 2n pi minus 2 pi by 3. Okay. See, basically there is also one more called least positive argument. Least positive argument is also there. Least positive argument is also there. So this also sometimes they will be asking the questions. Least positive argument. See, least positive argument is very simple. So generally it should be between 0 less than theta less than or equal to 2 pi. Least positive argument. So if you put n equal to 1, right, then you'll get least positive. That means 2 pi minus 2 pi by 3 is how much? 6 pi 4 pi by 3. This is your least positive argument. So here also if you see least positive argument, if you put n equal to 1 here, put n equal to 1. Put n equal to 1. So it will be 2 pi minus pi by 3, which will be here 4 pi by 3. Sorry, 5 pi by 3. Sorry. 5 pi by 3. Least positive argument means which lies between which lies between 0, which is actually greater than 0 but less than or equal to 2 pi. So you have to put in the general argument n equal to 1. You'll get it. Okay, so this is how we'll find the amplitude of this one. So in the next session, we'll be seeing the different forms of complex numbers. Okay, and keep watching these videos, and please subscribe to this channel, and also this is my website www.exercise.in. Here I'll be uploading many mock exams, and the content you can actually watch it for free, and you'll have mock exam simulators and practice exams also. Okay, I'll be also uploading once the concepts are completed. Then I also will work on the PYQs of mains exams, very important PYQs. And then I'll upload the notes also, PYQ solving notes also in the YouTube link. Okay, in the comment section. So yeah, please subscribe to this channel if you like it. Okay, then thank you all.